Hi class, today we are talking about solving polynomial inequalities. So we've learned how to solve polynomial equations, and we've learned how to solve linear inequalities, and now we're solving polynomial inequalities. So polynomial inequalities look something like this. So it's an inequality that contains an expression that's polynomial. So basically what this means is, when is this cubic above or equal to this quadratic? So if you go to GeoGebra, you can visualize what's going on here. So f of x equals 5x cubed, that's what's on your left side, right? Minus 2x squared plus 5. Okay, so there's the there's the cubic, and then we have x squared plus 4. Okay, so then I just will grab GeoGebra here and move it around. Okay, so basically, when is the green guy greater than or equal to the red guy? So they intersect here, so whatever x value this is, like maybe negative 0.5 or something, and then anywhere from negative 0.5 over, the green is above the red. And they don't cross again, it doesn't look like. So that visually is what's going on. So we have to be able to solve this visually, but most importantly, algebraically, so we get those exact answers. So algebraically, you're finding all values of x that satisfy the inequality. Graphically, you are finding the intervals over which the first polynomial is greater or less, depending on the direction of the inequality, than the second polynomial graph. So let's actually do one here. So let's solve when 2x plus 3 plus 3x squared, 2x cubed plus 3x squared minus 17x is greater than negative 12. So think, you're finding where the graph of the polynomial on the left, so the graph of this guy, so the cubic, is above the horizontal line y equals negative 12. So just like when we were solving polynomial equations, we move everything to one side of the inequality. Okay, so we would have 2x cubed plus 3x squared minus 17x plus 12 is greater than 0. Okay, we aren't dividing by a negative, we're just adding a 12, so we don't have to change the inequality. Now we have a new polynomial on the left side. Solving this inequality is equivalent to finding where the polynomial is above the zeros. In order to determine this, one needs to find the zeros. Okay, what I meant to say here, sorry, this shouldn't be zeros. It should be x-axis. Okay, so where the polynomial is above the x-axis. So this new polynomial, we want to figure out where is this guy greater than 0. So when is he above the x-axis? So we just need to find the zeros, and we do that by factoring. So we need to factor the polynomial to find the zeros. Okay, so because we need to know when it actually crosses the x-axis. If we figure out where it crosses the x-axis, then it's just another small step to finding out when it's above the x-axis and when it's below the x-axis. But first, we need to find out where it's actually crossing the x-axis, and we do this by factoring. So we set up our synthetic division. 2, 3, minus 17, and 12. And I know that 1 is going to work here. Okay, so this factors to x minus 1, and then we have 2x squared plus 5x minus 12. And we want to know when that's greater than 0. So then this quadratic factors, we have x minus 1, and then 2x minus 3, and x plus 4. We want to know when that is greater than 0. So notice now that we know the zeros are x equals 1, 3 over 2, and negative 4. So now we're going to use the fact that we know the end behavior of this cubic with the fact that we know the zeros of this cubic to draw a really basic sketch. So we're going to now sketch the polynomial based on the knowledge of the end behavior and the zeros. Okay, so this is a cubic with a positive leading coefficient, so therefore it goes in that general direction, right? From bottom left to top right. Okay, we also know the zeros are -4, 3/2, so 1.5, and 1. So 1 and 1.5. Notice that this is not at all accurate. My scaling is pretty terrible here. The only point of the sketch is just to figure out where it's above the x-axis and where it's below. So because I know my end behavior starts here, these all have an order 1. I can just go right through each of the zeros. Notice I didn't even bother to find the y-intercept. Okay, the whole point of this is now I can just see where this is above 0. So it's above 0 here, from here to here. So in this section, it's above 0. In this section, it's above 0. So now I just use my sketch to determine where it's above the x-axis. So notice that this was just greater than 0, so I don't use any equals to. So between 4 and 1, it was greater than 0. And then between -4 and 1. And then also when x is greater than 3/2. Okay, so that's where it's above 0. So this is the solution set to the polynomial inequality. Okay, you've solved it. So it's true. So now that means that our original question, so this original polynomial is greater than -12 for all x values between -4 and 1, and then greater than 1.5. Okay, so let's do another one. Solve this. Okay, so you guys can try this one on your own if you want. The first step, remember, is to just move everything over to the other side. So you get x cubed minus 4x squared minus 9x plus 36. So now that's greater than or equal to 0. So we just moved everything over. So now what you need to think about is this is some cubic, and you're finding when it is greater than or equal to 0, so when it's above the x-axis. So we're going to go ahead and find the zeros by factoring, make a really dumb, crude, basic little sketch, and just see where it's above 0. Okay, so we have to start with any factors of 36 that we're testing here in our synthetic division. Okay, and I will tell you that actually this one can be solved using grouping. I'm going to do that instead, just to give you guys just a refresher. You can also use synthetic division, but you can group together the x squared to get an x minus 4, and then take out the 9 and get another x minus 4. So you get x squared minus 9, x minus 4, greater than or equal to 0, so x plus 3, x minus 3, and x minus 4 is greater than or equal to 0. So now we just draw our little sketch. So our zeros are -3, 3, and 4. I know that this is a cubic with a positive leading coefficient, so I start down here, go through each of the zeros. They all just have an order of 1, and it ends over here. So I can see my solution set is between -3 and 3 and greater than 4. So now I write that. So the solution then is x when x is between -3, and I have the inclusion here because there's the inclusion there, and 3. And also x is greater than or equal to 4. So that is my solution to this inequality. Okay, so I know I say practice here, but I'm actually going to do this practice for you because it's a little bit confusing. So you move everything over, okay? So you get -2x cubed minus 8x squared plus 14x plus 20 is less than or equal to 0. Okay, so it's not very fun here having a leading coefficient that's negative. So what you can do is actually divide everything by -2 to get rid of all the -2's here, and then that means you'll have a lot simpler of a polynomial to factor. The problem is that you're dividing by a negative when you have an inequality. So that's just something, that's why I didn't want you to do this example by yourself. Okay, so you get this inequality that's a lot nicer to factor, but now you have to switch to greater than or equal to 0 because you've divided by a negative, okay? So remember, when you divide by a negative, you have to switch the inequality. So make sure that you really pay attention to that. Okay, so now you can go ahead and factor it. You can try the rest of it on your own. Okay, from here on in, I want you to try this on your own. So pause the video. You should get this as your answer. Okay, so this is true for all x's between -5 and -1 and greater than or equal to 2. Okay, now we have a word problem, so these will come up as well. A roller coaster is modeled by this with a very tiny a value, as you can see. H at t is the height in meters from the position x from the start. So when is the coaster more than 9 meters above the ground? Okay, so we're going to use a graphing calculator to solve this problem because it's so difficult to actually do on our own. So actually, we can also use CAS to do this as well. So if I go to GeoGebra, okay, and you go to the CAS instead of the graphing, you can actually put this in. All right. Here we go, CAS. Okay, so here's our input. So we have, we want to know when it's more than 9 meters above the ground. So first we need to find when it is 9 meters above the ground. So I have my 1, I'm going to put this in brackets, 1 divided by 4 million, okay, x squared, bracket x minus 30 squared, and then x minus 55 squared equals 9. Okay, so then I'm going to press x equals to solve. Okay, so these are all the different answers that I get. Ignore these $1, $2, $3. I don't know what's going on here. So I get all these different answers, okay? Some of them are in rational form, so you might want to change these into a decimal. So I happen to know that this decimal is, okay, we have 4.72, 21.7, 40, and 48.12, that should be. I don't know how we move this over. And then 58.58. Those are the answers that I have. Okay, so you know that those are the points of intersection. So if you go back over to your graphing, I can take these out, and you actually put in the graph, okay, f at x equals 1 over 4 million, and then x squared, x squared, x minus 30 squared, x minus 55 squared. Okay, we're going to graph what that looks like. I hope. Okay, you might have to use a graphing calculator. Wonder why that didn't work. Let me try h at x instead, because I have these other guys. So 1 over 4 million x squared, x minus 30 squared Here we go, x minus 55 squared. Okay, so here's what it looks like. That looks pretty cool. That's the roller coaster. Okay, and we want to know when it's equal to just y equals 9. Okay, so there is our y equals 9. So the question is, when is the coaster more than 9 meters above the ground? So it's hitting, we can zoom in on this a bit. Zoom in. So we can tell roughly where it's hitting, but we know the exact answers from our CAS. So we can see that this is just slightly less than 5. So that must be the 4.72 answer. And then this answer is between 20 and 25. So that must be the 21.7 answer. So we can say then between 4.72 and 21.7, it's more than 9 meters above the ground. Actually says more than 9 meters above the ground, so don't use the inclusion there. Just the less. Okay, so let's go back to the picture then. Okay, so then it's also 9 meters above, more than 9 meters above the ground here. So at 40, and then here. So that it's between 45 and 50. So that exact answer must be. Oh boy, now it went away. Okay, I don't know why I did that. It must be this 40, exactly 40, and this one, which if we had before, it's not this 58, because that 58 is over here, it's this one. So if you put this number into your calculator, you get that it is 48.12. So between 40 and 48.12, it also is. Okay, we can also see if we look back that it is after here, it's greater than 9 as well. But I mean, it's likely that the roller coaster is done by now and that this function only represents the roller coaster when it's less than 58 minutes, because it wouldn't make sense for the roller coaster to go like that forever. It might be fun, but not the whole time. So likely the roller coaster was done here. So you can say that in your response. That shows your understanding of the situation. So x greater than 58.58 also satisfies the inequality, but the ride is likely done by that point. Okay, so this type of question where it's not really factorable. Okay, well, it isn't factorable. You can still solve it using technology in an assignment or in your homework, but on a test, you wouldn't get a question like this unless it was factorable. Okay. The last one, does this have any solutions? Explain. So x to the power 4 plus 6x squared plus 3 less than 0. Does that have any solutions? Well, no matter what x value you put in here, when you take it to the power 4, that will become positive. And when you take it to the power 2, it will also become positive. And you'll also notice that you're adding 3 and multiplying it by a positive 6. So any x value that you put in has to be greater than or equal to 3, actually, because the lowest that can come out of here is 0. The lowest result out of here is 0. And same thing here. So the very lowest result you can get is 0 plus 0 plus 3, and that will never be below 0. That doesn't work. Okay, so no, it won't have any solutions because the output will always be positive. And that's due to the fact that there are only exponents of even degree and coefficients that are positive as well. Okay, so just to summarize this note, what you need to do to solve a polynomial inequality is move everything over to one side So you have all the variables and x's and everything on one side and just a 0 on the other side. Then you factor and find the zeros. And once you know the zeros, you look at the end behavior, draw a very rough sketch based on your knowledge of the end behavior and the zeros, and then you can look at that graph and conclude when the polynomial is greater than 0 or less than 0, as the case may be. And the solutions that are true for that graph will correspond back to your original question before you moved everything over. So this is one of those things you just need to practice and practice. Hopefully it makes sense to you, and if it doesn't, I'm always here to help. Thanks for watching, guys. I hope you learned lots.